All right, hello everyone. In this video, I am going to hit some highlights from problem 1, 2, and on the next page, problem 3. If I don't talk about the question that you're trying to check, you can pause the video to check your answers. But I'm just going to go over the ones that I think are sometimes confusing for people. All right, I'm going to start with what total distance did the object travel? So this is a distance time graph, and I spelled it out over here. But I can just read these numbers off the y-axis. So I went 20 meters up, then I rested 20 meters back, 20 meters down, 20 meters, and then I accelerated up to, and I guessed that number to be 33. So using those numbers, I got 113 meters. What is the displacement? That would be from where I start, position 0, up to my 33. So 33 meters is the displacement. All right, letter D says determine the average velocity during the time interval 14 to 18 seconds. Well, 14 to 18 seconds, technically I'm accelerating, which means my velocity is continually increasing. So determine the average velocity. So at the start of the story, I have a small velocity. It gets bigger, bigger, bigger at the end of the story. So to do the average, we just draw a secant line from the start to the top. In casual language, just draw a straight line, hook them together, and find the slope of that line. So I got 33 over 4, 8.25 is my average velocity. But that velocity in real life would be changing and getting bigger and bigger and bigger. It's probably more appropriate to talk about the instantaneous velocity. But when we aren't using calculus, we don't really have a good way of calculating the instantaneous velocity. So therefore, we estimate it. So it says estimate the instantaneous velocity at 17 seconds. So in 17 seconds, in the middle of here, I have to draw a tangent line. And so that curve, a tangent, touches that curve at only one point, that point being at 17 seconds. And so it's an estimate because, sometimes it's hard to figure out where to draw the tangent line. But this green line is my tangent line. And so I found my tangent line, and I know I drew it kind of long like this, but I used just this segment over here to find the slope of that tangent line. And so you can see I did my rise over run, and there was my work. And so I am estimating that the instantaneous velocity at 17 seconds is 7.5. And you can see that doesn't match my average velocity because it keeps changing. At the start of the story, the tangent line would not be very steep. So the average velocity is going to be much smaller, but it's only getting bigger and bigger and bigger and bigger as time goes on. So again, it's just an estimate. All right, on the bottom of the page, it's a velocity time graph. And one of the things that I do on a velocity time graph is I always write down anything above the x-axis is happening in the positive x direction. Anything down here is happening in the negative x direction. So you can see that at the start of the story, my object is traveling 12 meters per second in the negative x direction. So letter B, describe the motion between 6 and 12. So I know I'm going in the negative x direction. And I look at the numbers 12, 8, 4, 0. They're getting smaller, so I'm decelerating in the negative x direction. So that makes sense. All right, letter E. What is the displacement of the object from its starting position? Well, on a velocity time graph, you don't really know what the starting position is. All you know is the velocity of the object. So I'm just going to pick a starting position, and I put this little blue dot here. That's going to be my starting position. And during the course of this object moving, it moves in the negative x direction, these distances. So I found the area under the curve, and that's how far, if I add up all those blue numbers, which I got 140, that would be how far I went in the negative x direction. So I drew an arrow going in the negative x direction. But in the middle of the motion, I also spent some time going in the positive x direction. So I found the area of that, and I got 96. And so I went 140 in the negative x, I went 96 in the positive x. And so displacement would be from where I started to where I ended up. So in casual language, it always turns out to be the big area minus the little area. And in this example, the big area was the negative x minus the positive x area. All right, on the next page, we are going to look at the corresponding graphs. And I know some of you asked me about these today. And so I thought it would be a little bit easier to do and a little bit more slow to do. I can go through it more slowly in the video here. Okay, so we are given the velocity time graph, and we have to construct the acceleration time graph and the distance or displacement time graph. I think it's easiest to look at the velocity time graph and extract my data there. So, for example, I can see that changes are happening at 2, 4, 5, and 8 seconds. So yeah, I'm going to change this 6 to a 5. I should have typed that as a 5. All right, that's going to help. All right, so at the start of the story, I can see that the velocity is 2. So I'm going to write down 2 and 2. It is not 2, it's 4. 4 and 4. All right, so 4 and 4. And then I have this negative slope going on here, and that would be like an acceleration slope. Technically here I am decelerating in the positive x direction, and then I am accelerating in the negative x direction, but either way it's a negative slope. And so that velocity at 4 seconds is when I switch directions, so that's 0. And then I can see at 5 seconds, I'm going -2, and in 8 seconds, I'm going -2. So I'm just going to fill those in. I'm not sure how helpful that is, but I'll store those there. All right, so the acceleration time graph, I think it's easiest to do the acceleration time graph by just looking at the velocity time graph and kind of talking to ourselves. So look at the y-axis here. I'm going to kind of draw it up so it extends a little bit. You can see that the x-axis is kind of like in the middle here. And so this is -1, this is -2, and I don't have any positive values on here. So this line here is actually 0. So at the start of the story, I'm going from 0 to 2 seconds. I am moving at a constant velocity. That means I'm not accelerating. So my acceleration would be 0. So I'm going to just kind of draw a line here at 0. And then I do have an acceleration here. It's a deceleration. And so this slope here, this entire segment has a slope of -2. So from 2 to 5, so I'm just going to make a mark down here from 2 to 5 seconds, it's -2. Just make that kind of nice and dark there. And then I can connect this with a dotted line. All right, and then from 5 seconds to 8 seconds, I'm back at a constant velocity again. That means that I'm not accelerating. So from 5 to 8, I need to make this on the 0 line again. And then I can connect this like this. So that's what the acceleration time graph would look like. So now we have to reason out the distance time graph or displacement time graph. All right, so I'm going to put down at time 0, I haven't gone anywhere. All right, but after 2 seconds, how far did I go? So I could just find the area under that curve, and it would tell me how far that I went. And that area is 2 times 4, that's going to be 8. So at 2 seconds, I would be at position 8. From 2 to 4 seconds, if I find the area of this triangle, it's going to turn out to be 4. So at 4 seconds, I've gone 8 plus 4, I would be at position 12. All right, but at position 4, I am now changing direction. So I have gone in the positive x direction 12, but now I'm going to start going in the negative x direction. So from 4 to 5, this little triangle here, I'm going to find the area of that. And it turns out to be 1. So let me say it again. I'm up at positive 12, but I'm now walking backwards 1. That's going to put me at position 11. And then from 6 to 8, we'll find the area of that. So that's going to, I'm sorry, not 6 to 8, 5 to 8. So that's 3 times 2. 3 times 2 is 6. Did I do that right? I did. 3 times 2, 6. So I'm at 11. But again, I'm in the negative x direction. So 11 minus 6 is going to be 5. And now I'm just going to graph these out. So at time 0, I'm at 0. At position 2, I'm now up to 8. At position 4, I'm up to 12. And at time 5, which is this dotted line, I'm back 1, I'm at 11. And then at position 8, I'm at 5. And I won't call this a connect the dot, because this is going to be kind of like a curvy line. So it's going to kind of parabola up. I missed my dots. And parabola down. I missed that dot. Okay, so I hope that makes a little bit more sense and can help you finish up those problems. I'll do some more videos to walk through the other ones.